Namaskar. Today's topic is on thawing of silk. This topic deals the various preparatory processes involved in the preparation of raw silk. Silk has set the standard in luxury fabrics for several millennia. The first country to apply scientific techniques to raising silkworms was Japan, which produces some of the world's finest silk fabrics. Other countries that also produce quality silk are China, Italy, India, Spain and France. China was the largest exporter of raw silk in the early 1990s, accounting for about 85% of the world's raw silk, worth about $800 million. Exports of China's finest finished silk products were about half of the world's total at about $3 billion. Silk is highly valued because it possesses many excellent properties. Not only does it look lustrous and feel luxurious, but it is also lightweight, resilient and extremely strong. One filament of silk is stronger than the filament of the steel. Although fabric manufacturers have created less costly alternatives to silk such as nylon and polyester, silk is still in a class by itself. Throwing is a process of twisting of one or more threads of a raw silk into a strand sufficiently strong for weaving and knitting. It is a process of preparing the raw silk for loom by twisting and doubling it to the required strength and thickness. Throwing is a word derived from the Anglo-Saxon word thrown, meaning to twist. Before raw silk is put in loom, it is processed and made into a substantial yarn, though all silk do not require complete processing. The entire operation is known as throwing and the yarn thrown silk. Silk throwing or processing differs, however, from given to wool, worsted or cotton stock. Silk throwing means actual twisting without drawing of continuous fibers or filaments. The thrown yarn is sold under various names as thrown, tram, organzine, grenadine and sewings. The throwing operation covered several processes which will include soaking, winding, doubling, up-twisting and conditioning. In silk throwing, skeins of raw silk are soaked in soap or oil based emulsion to soften the sericin, which promotes the best separation of filaments during the reeling. It also imparts smoothness, adaptability and increases the hygroscopicity of the filaments and increases their capacity to take and hold the electric charge. The raw silk skeins are sorted according to size, color and length and quantity. These are then soaked in warm water with soap or oil. This softening of sericin aids in handling the thread. After mechanical drying, the skeins are placed in light reels from which the silk is wound onto bobbins. During this winding operation, single strands may be given any desired amount of twist. If two or more yarns are to be doubled, they are twisted again in the same direction or in the reverse direction depending on the kind of the thread that is to be made. Soaking. The objective of soaking is to soften the gum. Sericin lubricate the thread and make it more pliable and ductile. The agents used are soap, oil, borax, salt and water. The water should be soft and free from acids and alkalis, and the soap should be preferably be an olive oil or coconut oil soap. The soaking process is also called sizing, and the application varies according to the requirement of the weaving. The skeins are thus soaked in solution with varying proportions of softening agents. In another kind of sizing, where the thread has to be lubricated and given a high twist, like singles and crepes, the solution contains fats and hydrocarbons besides the soap. In India, the raw silk hanks are soaked before winding in cold water, oil and soap dissolved in it. The hanks are kept in the solution overnight, and the next day after the water is wrung out, the hanks are kept in the open for drying. Winding process. The objective is to transfer the raw silk from skeins to bobbins, which are thrown and converted to skeins. Various types of winding frames are used, but the flat ones are popular since they could be used also for man-made fibers. Winding should be done under relative humidity of 80 to 85%, and the speed of winding may vary from 50 to 100 meters per minute according to the denier of the thread. The second winding or rewinding is sometimes called cleaning the bobbin to bobbin. The rewinding process also helps to give stretch through the thread and remove knots and irregularities in the silk. The rewinding frame is similar to the winding frame but is provided with a device called the stripper to clean the thread. Rewinding is necessary for only inferior or dirty silk where the thread breaks during the winding process. If a dirty or a bad knot is caught, rewinding is done in a dry premises and at a faster speed than a winding speed. Doubling. This means combining two or more threads from as many bobbins and winding them onto a single thread on another bobbin. The winding frames are broadly classified into two types, one with radial winding and the other with axial winding. The former is used for fine threads and the latter for heavier threads, though the procedure is identical on both the devices. An important feature of the doubling frame is the automatic mechanical stopping device, which stops the turning of the bobbins if any thread breaks during the process. In the modern frame, there is an automatic electric device which helps to detect a breakage during doubling. It is difficult to double more than 6 threads, and the inequality of tension in threads which are double leads to false twist and poor throwing. Doubling should be done in dry conditions. In the indigenous methods, doubling is done sometimes by combining threads from swift to hand reels. Twisting. The throwing operation is completely mechanized in Japan, China, the USSR and Europe, though in India still follows the indigenous methods of hand twisting, at least for half of the country's total silk output. In Assam, West Bengal and Benares and a few other parts of the country, most of the twisters hand twist the yarn. In hand twisting process, a professional twister called Chembalia works on the two bamboo poles tied with the cross slips raised vertically on the ground. Several such pairs of poles are raised in the open, and the cross slips are further divided into 10 sections by binding a vertical thread passed from one end to another through the first thread, passed from one end to another through the first section and retrieved to the second. Threads are similarly arranged in another sections, and 10 free ends are broken and small spindles are attached to them. These spindles are hand turned so as to twist the thread. Twisting is completed when the ends shorten up to 3 feet, which is almost half the original size. Afterwards, a fresh thread is tied to the end in section 1 and the end in section 2 is tied to a bamboo reel. The ends are pulled in and wound on the reel. Fresh threads are supplemented in all the sections similarly and the twisting continues. Though machine twisting is superior to this crude method, the costly brocades and famous Benares saris are the products of this hand twisted yarn only. The other improved twisting devices used by the Indian roisters include a wheel fitted with the metal spindles and rotated by a belt. Usually, several spindles are operated with a separate belt from the reel. This system has several variations like a big wheel turning several spindles by a single belt. Yet another model of a hand twisting machine functions like a power machine. A vertical spindles on both the sides are turned, each by a separate belt from a horizontal drum turned by an operative. Other belts from the axle of the drum move small reels on both the sides on top of the spindle, each reel receiving the twisted yarn from its corresponding spindle. All these mechanical devices resemble early European twisting devices. In the mechanized throwing process, the bobbins are transferred to twisters for converting a single thread into organzine for warp. A single twisting generally gives the silk 30 twists per inch, 2.5 centimeters. The single twisted thread collected on cups are then taken to a doubling or tripling machines, which twists the yarn for a second time. The resultant twist in the organzine would be 15. The twisted yarn is now ready for warps. The throwing units prepare warps for 32-yard lengths with 5,500 to 5,600 threads. In case of tramp silk, which is used for weft by a weaver, the winding bobbins are shifted to the doubling or tripling machines and the thread is made into 3-fold or 4-fold as required by the weaver. This thread is given a light twist 7 to 8 twists per inch in twisting machine. This twisted yarn in hanks are packed into bundles and supplied to the handloom weavers. India's main silk throwing center is in Bangalore, where some 10,000 twisters work on 80,000 spindles worn by some 60 to 70 units. The size of the silk throwing unit varies from small shed plying over 100 spindles to a large factory equipped with 2,000 to 3,000 spindles. The power loom weaving units have their own twisting machinery which make up warp lengths of 100 to 200 meters depending upon the type of the fabric. Mechanized twisting has greatly developed in Japan, China and Korea. The old throwing frames with rotatory spindles have been placed to large modern package twisters with complete automatic devices. The European throwing frame made of either wood or metal has rotatory spindles from which the twisting threads are drawn and wound. The frame has 2 to 3 or 4 stages, each having 95 to 56 spindles turning at the speed of 10,000 revolutions per minute. Throwing is denominated by the number of turns per meter and twist may be either clockwise or left twist or anti-clockwise or right twist. The former is symbolized by letter S and the latter by letter Z. Types of silk threads. 4 different types of silk threads may be produced by the throwing process, which includes thrown, singles, tram, crepe and organzine. Thrown singles or individual raw silk threads that are twisted in only one direction. The number of turns depends on the quality of thread desired. Usually 3 to 8 strands of silk filaments are twisted together in one direction to form a yarn called a single. The loose twist single consists of 2 or 3 twists per inch and are used for weft yarns. The hard twist singles have a greater number of twists per inch and are used in a sheer fabrics. Tram is made of 2 or more singles twisted and doubled and is used for the weft of various fabrics. Organzine is made of single twisted one way, then doubled and twisted in the opposite direction. This is used for the warp of heavy fabrics. Crepe is similar to organzine but is twisted to a much greater extent. Crepe thread is employed in the weaving of characteristic crinkly fabric and single thread is used for sheer fabrics. Other methods of yarn preparation. Number 1. Coning. Coning is a term applied to form of preparation of yarn that is particularly valuable when the yarn is to be used on a knitted machine. The machine on which the yarn is prepared is called a conner, is equipped with a series of horizontal spindles that are individually driven. Number 2. Coping. Hard twist filling yarn for a weaving mill is often prepared on cobs or cob tubes instead of shopping bobbins, the object of being to prepare the yarn so that the manufacturer or the weaver may use it immediately without further preparation. The machine on which the cobs are wound is known as cob winder or as a copper. Quilling. This is yet another form of yarn preparation that is similar to coping, is known as quilling. It is performed on a machine that is like a copper in all aspects except that quills are used instead of cobs. A quill resembles a cob in shape, but it has wide base or shoulder that form a foundation for the yarn. The cobs or quills once filled with the hard silk are usually treated to set the twist on the silk. The last stage of operation in silk throwing is steaming. The final stage of silk throwing operation is steaming or conditioning, whereby the twist given on the thread is set. This is done by exposing the thread to the action of damp heat in the steaming chamber at a temperature of 70 degrees centigrade. The organzine thread is steamed for about 10 minutes, while the highly twisted yarn require a little longer. The steamed silk is then dried in another chamber at a temperature of about 60 degrees centigrade maintained by radiators. The object of steaming is to eliminate twist liveliness or snarling associated with twisted yarn.